Hi my dear student, today we will discuss exercise 1.1 15th problem, which is an application of matrices to cryptography. A small introduction, how we are going to use cryptography in the topic of matrices. For example, let us take the matrix A as encoding matrix. Okay, whose inverse is decoding matrix. Okay, now suppose uncoded row matrix is given. Uncoded row matrix is given. When you multiply uncoded row matrix into encoding matrix, it gives coded row matrix. Okay, now the coded row matrix multiply with decoding matrix, it gives decoded. That's all. That is the output. I will repeat. If I am taking the given matrix as encoding matrix A, whose inverse is decoding matrix. If uncoded row matrix is given, multiply with encoding matrix, it gives coded row matrix. Now, the coded row matrix multiply with the decoding matrix, it gives decoded. That is result. In example, uncoded row matrix is given. So, you are multiplying with encoding matrix, it gives coded row matrix. Now, coded row matrix multiply with decoding matrix, it gives decoded. For example, if I am taking uncoded row matrix as some B. So, B multiply with encoding matrix A, it gives C. Now, this encoded row matrix multiply with decoding. So, BA. C is a coded row matrix. And I am taking decoding matrix. That is A inverse. And here also. So, by associative property, A inverse will come. And A inverse is an identity matrix. Then B into I become B. So, it gives the output. That is what? Decoded. This is an example which is given in the textbook. I will explain. I am taking the encoding matrix as A. Decoding matrix as A inverse. Then, if uncoded row matrix is given, when you multiply with encoding, it gives coded row matrix. Then, encoded row matrix multiply with decoding matrix, it gives decoded. In this case, uncoded matrix I am taking as A. Then multiply with an encoding, it gives some coded row matrix C. Then I am going to operate C with the decoding matrix A inverse. So that is C A inverse, which is decoded. So how it will be decoded? So the left hand side process, C is nothing but B into A. B into A into A inverse. By associative property it will be split. A inverse is I is B. So that is B. So B is C A inverse. So uncoded row matrix become decoded in this way. This is an example given in the textbook. But in exercise 1.1 15th problem, they gave coded row matrix. In exercise 1.1 15th problem, coded row matrix is given. Coded row matrix is given. So what do you want to do? Coded row matrix into decoding gives decoded. Result will come. What is decoding? Decoding means you want to take inverse for the given matrix. Let the given matrix as A. That is encoding. Given matrix. Whose inverse is decoding. Very simple. Now an example, uncoded given, that's why uncoded into encoding is coded, coded into decoding is decoded, result will come. But in exercise 1.1 15th problem, listen, exercise 1.1 15th problem, what is given? Coded row matrix is given. And the given matrix has encoding. So now you want to decode it. Very simple. So coded row matrix is given, coded row matrix into decoding matrix, it gives decoded. That's all. So in exercise 1.1 15th problem, simply let us take the row matrix as coded row matrix, multiply with decoding matrix, that is A inverse, it gives decoded. The result will be the output. Now exercise 1.1 15th problem, the given matrix as A. I'll take, let the given matrix as A, minus 1, 2, 1. This is what? Encoding matrix. Encoding matrix. Now find out decoding. A inverse. What is A inverse? 1 by determinant A into adjoint A. What is determinant A? Minus 1, 2, 1. It gives minus 1, change the sign, it will become plus 2, 1. And adjoint A. Adjoint A for 2 by 2, interchange the leading diagonal, sign change in the subdiagonal. So it become 1, it become minus 1 when interchange, plus 2 become minus 2, minus 1 become plus 1. Therefore, A inverse, 1 by determinant A, 1 by determinant A is 1 by 1 is 1, into adjoint A, it will be like this. Now this is what your decoding matrix. Okay, so the given matrix is encoding matrix, whose inverse is decoding matrix. In this case, the given row matrix has coded row matrix, which is 2 minus 3. This is given. This is coded row matrix. Coded row matrix. Coded row matrix multiply with and decoding matrix, it gives the decoded. See, 1 row 2 columns, 2 by 2, it become a row matrix. First row first column, 2 ones are 2, minus 3 into minus 2 plus 6. Next, first row second column, 2 ones are 2 and minus 3 into minus 1 plus 3. It gives 8 and 5. Next, another row matrix is 20 and 4 into, this is coded row matrix, into decoding matrix. First row first column, 20 ones are 20, 4 times minus 2 will be minus 8. And first row second column, 20 ones are 20, 4 into minus 1 minus 4. It gives 12 and 16. Therefore, sequence of the decoded matrix are 8, 5, 12, 16. I will repeat. In this case, sequence of the decoded matrix are 8, 5, 12, 16. Now let us consider the sequence of numbers 1 to 26 as A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now the output is 8. What is 8? H. 5. E. 12. L. P. 16. P. So the output is L. So the receiver reads the message. Therefore, receiver reads the message as L. The receiver reads the message as L in this case.